So today I'm going to show you an example of how to use your calculator to find lines of best fit and correlation. So you're going to have here, we have an example of different cars and their price in thousands of dollars versus their miles per gallon, so their fuel economy. So in order to do this, you want to put your data into your lists. Remember, you clear by going up to the list title, hitting clear, and arrowing down. So I'm going to put it in just as it says here in the problem. Nope, 14.5, 19.2, 17.1. Okay, and then we'll go over to list 2. You do want to make sure that the data lines up because these are points. They are tied together. So every once in a while I'm doing a little check here. 38, 33, 25, 33, 41, 28. Okay. All right, so now that the data is in, I want to go to second stat plot. My plots are already on, but I need a scatter plot, which is the first type. My list 1 is my X list. My list 2 is my Y list. And I'm going to do zoom 9 so I can look at my data here. It appears, knowing that this is the price, that as the price goes down, or the price goes up, the miles per gallon goes down. That's kind of interesting, that the more something costs, the more a car costs, the worse fuel economy it is. I find that kind of interesting. Okay, so now if we want to put in a line of best fit, we want linear regression, and with statistics, you want this version of linear regression where your y-intercept is by itself first, and then your slope in x. So I want my linear regression. My X list is list 1, my Y list is list 2, and I'm actually going to store my regression into Y1. So if I go to vars, yvars, function Y1, we'll actually put in there that I want to store it in Y1. And then I want to calculate. Now, if your calculator doesn't do this, I'll show you how to store it in Y1. Okay, so my equation here is 45.44 minus or plus negative 0.69x. So if I didn't have that store ability easily, if you have a non-84 plus silver that you're working with, you would just write these down. So I'm just going to jot these down, jot my equation down. It would be y equals 45.44 minus 0.69x. And then you would just go into y equals and put that in. So now if I go to my graph, my line of best fit is there. Okay, it looks like a pretty decent line. Okay, the strength of my line is pretty good. Let's see, go back to my problem here. Okay, the strength of my line, it's pretty strong. The points are pretty close to the line, and there definitely is a negative trend. Now, in order to kind of verify that trend, notice that when I did that calculation, it didn't give me my regression, which means my diagnostics are not on. So I want to go to my catalog, and I'm going to go to diagnostics. I need to find the D here. There we go. So I'm going to go to diagnostics. Remember, there is a video that she shows you, how to do that. So we go to catalog. We're going to find diagnostics on. We want to hit enter twice. Now, if I go to calculate my linear regression. Now it will show you my correlation coefficient and my coefficient of determination. So my correlation coefficient is negative 0.7756, meaning it's an okay fit. It's negative, so that does mean that it's a negative relationship. As one goes up, the other goes down. And 0.775 isn't too bad. It's okay. It's an okay fit. It's okay strength of relationship. Looking at the coefficient of determination, 0.60. So that means 60% of the variation in my Y values, in my miles per gallon, can be attributed to my X, to my price. You really want your coefficient of determination to say it's a strong relationship. You want R squared to be 0.8 or higher. So not quite as strong as we'd like. We would call this a moderate relationship.